states when electrons occupy orbitals of equal energy, meaning they're in the same level, okay? One electron enters each orbital until they all contain one electron with parallel spins. This is different from Pauli's exclusion principle that says that they're going to actually fill opposite, opposed, okay? Here's the difference. So I want you to flip, and this is how we find how many unpaired electrons there are. So the question is, who cares how many unpaired electrons there are? The unpaired electrons are actually one of the most important parts of the atom. Those are the electrons are the ones that are involved in bonding. So if there's a chemical reaction that took place, in other words, you had some major thing that happened when you mix two chemicals together, it's actually the electrons that are interacting with each other. And the number of unpaired electrons, we'll do this later, so right now it doesn't seem like it's that important, but when we get later in the year and we talk about bonding, it's all the electrons that are doing all this stuff, okay? So I want you to flip the page to this page right here. And we started talking about these up and down arrows. And so what Hund's rule states is that the electrons will actually fill parallel in one sublevel, and then they'll fill opposed. Why? The scientists calculated that it was more stable that way, okay? So they said instead of having one cloud with an up-down, and when you have three empty clouds, they would fill 1, 1, 1. So watch how this works. So we talked a little bit about this, and we said that every circle here represents one cloud or one orbital, okay? And in one cloud, you can only have two maximum electrons, again, because one's spinning plus 1/2, the other one's spinning minus 1/2, okay? So we did 1s2, 2s2, 2p6, 3s2, 3p6. Something happens funny at 4s. Remember, it goes 4, 3, 4? So here's our 4s. Let's fill this one in. S is only one orbital or one cloud. So we're going to get 2 electrons maximum, one up and one down. But if you had 4s1, like something like potassium ends in a 4s1, you would just have one electron in there. All these would be filled, and then you would have a 1. But we're going to shortcut it, okay? Let's do the 3D. So remember, by Hund's rule, the way it goes is it goes 1, 2, 3, 4, 5, and then we're going to come back and fill 6, 7, 8, 9, 10. So Hund's rule tells us that we fill parallel first. Okay? Pauli's exclusion principle tells us that when they do fill into the same orbital, they fill opposite, they fill opposed. Okay? So Hund's rule says go parallel first. Pauli's rule says, but when they're together, because electrons are both negative and they would repel, they must be spinning opposite of each other. Okay? And then the 4p, why is there 1 circle for the S, 5 for the D, and 3 for the P? Why does the P only have 3 circles? What is that representing?
That's how many clouds it has.
Good, because in the P you can have a PX, what else? PY and PZ. Okay? Everybody skip all the way up. Let's just do one of the Fs. So F has 7 orbitals, which is why we have 7 circles, but then how many electrons can you fit in there?
14.
14. So it goes up, 2, 3, 4, 5, 6, 7, then back down, 8, 9, 10, 11, 12, 13, 14. Okay? But it may not be all filled. Depends on how many electrons you have. So again, we talked about hydrogen, and we said that hydrogen has 1 electron if it's neutral. But if hydrogen's a +1 charge, how many electrons does it have? 0. None of this would apply. If you had hydrogen with a +1 charge, it doesn't have any clouds. That's like, would you have a cloud without having water vapor? Like an actual cloud up in the sky? Would there be a cloud without the water vapor? No. There's no cloud without the electron. The electron is what makes the cloud, okay? Just like water makes a cloud in the sky. Same thing here, okay? So if you don't have the electron, you don't have the cloud. Does that make sense? So let's come back a page. And the first thing I want to do in Hund's rule, S. How many cloud shapes will you have for the S? Sphere. Only 1. You're going to draw 1 cloud. That means 1 orbital. Okay. P. How many clouds can you have for the P, which is the dumbbell shape? 3. We're going to draw them together. 1, 2, 3. So this one has 3 orbitals, which means we could have 6 electrons maximum. Px, Py, Pz, or they can call it -1, 0, and 1. So there's 2 electrons in each cloud. D, the clover shape, how many did we say? 5. 1, 2, 3, 4, 5. So that's 5 orbitals. And what about the F? 7. And then we're going to use Hund's rule to say up arrows first and then down arrows. So let's do just hydrogen real quick. So let's do hydrogen, and hydrogen's electron configuration would just be 1s1. So if it were neutral, that means that I would just have 1 circle, and how many electrons? 1. So I would just do 1 up arrow. That's called an unpaired electron. They call it an unpaired electron because it's not paired to any other electron. So they call it unpaired. And the unpaired electrons are the ones that are involved in bonding. Okay? So let's try oxygen. All right, so I need someone to please give me the electron configuration, the noble gas one, the kernel method, for oxygen, please. Okay.
Helium.
Good?
2s2.
Good.
2p4.
2p4. Awesome. So let's write that down. So it's helium. Write it up here, please. So in brackets. And helium is a 2. And then we said 2s2, 2p4. Okay, then under what we're going to do is we're going to draw orbital occupancy diagrams. So meaning that these are orbitals and electrons are occupying them, so they call them orbital occupancy diagrams, and then they're diagrams. So let's do the S. S is just 1 circle. So 1 circle, 2 electrons. So I'm going to do 1 up and 1 down. Now let's do the P. How many clouds does a P get? 3. Awesome. So I'm going to draw 3 clouds together, leave a space between the S and the P. That way we know those are 2 different sublevels. Okay? Now we have 4 electrons, not 6. So should I do 1 up, 1 down, 1 up, 1 down?
No.
No. The scientist said, Hund's rule says, what do you do first? Up, up, up. Awesome. Up, up, up. And then where does my 4th one go?
Down.
Down. Now, these are incomplete. What happens is, if there's another element that has 2 extras, they can actually share. And then that's how bonding ends up working out. It's really cool how it all works together, okay? So, how many unpaired electrons are there here? 2. Okay. So let's do germanium instead. Okay, first on top, let's write the electron configuration using the kernel method. Okay? So someone want to do germanium's right here. Someone want to do the kernel method. Somebody new.
Okay, so it's argon.
Good?
And then it's 4s2,
Mhm.
3d10,
Perfect.
4p2.
Awesome. 4p2. Very nice. Okay. So we've got, okay, so argon has 18, and then it's 4s2, 3d10, and then 4p2. Okay, so let's draw this out. So you only have to do it past the noble gas. So for the noble gas, you're doing nothing, okay? You can only do the ones after. So S has how many clouds?
1.
1. I'm going to do 1 cloud for the S, 1 up and 1 down because it's got 2 in there. The D has how many clouds? 5. Good. So let's do 1, 2, 3, 4, 5, all connected. Now, when you write it on paper, it looks the same whether you used Hund's rule or not for this one, but not for the next one. So I'm just going to go up, 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 and then come back down. Again, it would look the same if you did up, down, up, down, up, down. All right, in that case. And P. How many clouds does the P get? 3. So now I'm going to do my P, and it's 1, 2, 3, and now I only have 2 electrons. So do I do 1 up, 1 down in the same circle, in the same cloud? No. I have to do 1 up and another 1 up. The last one's blank. That is an empty cloud, which means it doesn't actually exist. Okay? So that cloud, the clouds are only there if the electrons are there. So how many unpaired electrons are there? 2. Awesome. The unpaired electrons are those. That's called an empty cloud. That's not an unpaired electron. Okay? And that's Hund's rule. All right? That's it for Hund's rule. So we're going to take a look at the packet next. Okay? But that's it for